Okay, so we're looking at exercise 11C from the first year mechanics textbook in question 4. So we've got a particle moving along the x-axis and we're given its velocity in terms of time. First thing we're asked to show is that P never comes to rest. So if it did come to rest, that would be when its velocity was 0. So we've got a quadratic and we're basically trying to show that that never equals 0. So you've had this type of problem come up before in core maths. Okay, so we've got that V is 2t squared minus 3t plus 5. So basically we're trying to show that this quadratic never equals 0. So you've got two options. You can use the discriminant. Okay, that would work. Or we can complete the square. So complete the square is normally the sort of quickest way to do it. So I'm going to do it that way. And bear in mind, if you're not sort of keen on completing the square, you can just get the vertex from your calculator and sort of fill it in from there. So I'm taking out a common factor of 2. Then I'm completing the square. And I'm choosing to just leave the 5 set separately throughout all this. So then I'm going to multiply through by the 2. And then just tidy all that up. Okay, so like I said, if you're not really happy completing the square, you should practice that because you might be asked to do it. But you can get around that by using the quadratic solve mode on your calculator to get the vertex, and then just work it back from there. Okay, so I could then go to a sketch. So from that, I can see the vertex is at 3/4 31/8. So and you could have got that from your calculator and then put it back into the completed square form. And as long as you acknowledge that it was 2t squared, so you would need a coefficient of 2 there. So I could then go to a sketch. So I know that it's a positive quadratic, so I know what shape it is. I know the y-intercept is at 5. So I've got a y-intercept of 5 and a vertex of 3/4 31/8, and that's velocity against time. So and then I could also justify it just from looking at the algebra though. So I could say that t minus 3/4 squared is always greater than 0 because it's squared. So multiplying that by 2 won't change anything. But sorry, that should say greater than or equal to 0. But if I add 31/8 to that, that will always be greater than 0. Okay, so you can use either of those. You can use the discriminant. Either way, I would include a sketch because they need to know that you've realised it's a positive t squared graph, so it's a U shape. So which either of those I go down, I can then conclude that V is, I was going to put as net or negative, but let's put is always greater than 0, and then I'll just really clarify that I know that that means it's never stationary. Okay, so there, that probably was a little bit overkill in the amount of working I did for that, but just to really cover all bases. Okay, and then find the minimum velocity of P. Okay, so this actually probably a little bit nicer. So minimum, maximum for this type of question, it's always going to be differentiating and finding a stationary point. So, so V is 2t squared minus 3t plus 5. So from after a stationary point, I want to differentiate. And then set it equal to 0. So there is only going to be one stationary point for this. Okay, so assuming that's the case, they're not going to set a trick question. So I don't need to justify whether it's a maximum or minimum if it's the only stationary point. If you're at all unsure on that, though, it certainly wouldn't hurt to do the second differential and just clarify that as that is the only stationary point, I'm going to assume that's got to be the minimum. But I've got to be really careful to complete the question. So I have found the value of t where the velocity is a minimum. They've asked me for the actual minimum velocity. So I just need to go back to the expression for velocity and substitute 3/4 into that. Okay, so really quickly. Okay, so let's just double check. So that's giving me 5.3125. So that would be 5.31 to 3 significant figures. Let's just double check. Oh, I did type that into my calculator correctly. And okay, so I didn't. Right, sorry, let's just really quickly check that that wasn't just a calculator error. That's probably, yes, it was. I put plus instead of times. Okay, so scrap that. That's what happens when you're rushing. Okay, let me just double check that it does give us the right answer. 3.88. Yes, that's more like it. Okay, so sorry, so that should have been 3.875, which would be 3.88 to 3 significant figures.